Okay, so we will proceed. We will uh, we will commence a new topic, that is vector field. And in the vector field, we will see kind of line integral. So mostly whatever we have seen is calculus over calculus over mostly whatever we have seen, that is calculus over algebra. So calculus over algebra, this is what we have seen. Now calculus over vector, but calculus is game of algebra. I mean calculus over vector is calculus over advanced algebra. So rather than calling it as a changing the topic from algebra to vector, we are promoting algebra to advanced algebra. Algebra which has a direction. Earlier, we had algebra which was a set of points. Algebra with set of points. Now, algebra which has direction. Direction. Okay. So, things would I would say, if you are moving into advanced stage from algebra to advanced algebra, then certainly calculus would move to advanced. What is meaning of advanced is we can do more. Now calculus would cover broader area. So now calculus algebra is moving into calculus vector, where 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 so that we will see. Okay, so suppose that kind of I have a circle. Suppose I have a circle. I have a circle. If I have a circle, then what is the point is addressed through? If these are the points along the circle, then each point, how I can address? Each point is addressed as x comma y. Each point along the perimeter of circle is addressed as x comma y. Okay, where this is x-axis and this is y-axis. X-axis, y-axis. X is independent component and y is dependent component. Y value is dependent upon x value. X is independent. Y equal to function over x. Y equal to function over x. So if I have a Python function and that accept x as parameter, then it will return y, that is function over x. So x is input. Inside the function, it will do some kind of mathematics on x and it will return y equal to function over x. Simple. I mean, I can call like this in Python, y equal to, the function name is f and in braces x. Function over x, result is y equal to fx. So if I have any point x comma y where y is dependent upon x, fx, then I call every point here on the circle parameter is x comma fx. X comma fx. Now it depends upon what is fx. So if it is a circle, so x square plus y square equal to a square, a being the radius. If that is true, then y equal to a square minus x square square root. So every point on the circle can be addressed as x comma a square root of a square minus x square. Okay. Now each point, so this is algebraic equation. So algebraic equation of if I have a circle, then each point on the circle can be addressed as x comma square root of a square minus x square. So y is a function over x. Y equal to fx equal to a square root of a square minus x square. So if the points of a curve, if it is a curve and point of a curve is a x comma square root of a square minus x square, someone can immediately say it is a these are points on a curve, but curve is a parameter or boundary of a circle. Now, if I have any point P and coordinate of P is x comma square root of a square minus x square, then there is another hidden point, that is origin. If this is the origin and this is P, if I draw a line from origin to P, then it makes a vector. Okay. Now I can say that P point, the coordinate of P point, any P point on the perimeter of circle is x comma square root of a square minus x square, or xi plus square root of a square minus x square j. That is called vector form of the algebraic notation. So if I have algebraic coordinate point in algebraic form x comma a square root of a square minus x square, then that can be represented as vector. Vector is nothing but energy which has a direction and which has a magnitude. Okay, if that is the case, then this vector has a direction. Direction is from origin to point x comma square root of a square minus x square. That is the direction. If that is the direction of a vector, then we deduce the vector from these 2 points, we subtract one point to other point, and we get the vector equation. So one point is x comma square root of a square minus x square, other point is 0 comma 0. So vector is xi plus square root of a square minus x square j, because 0 0 got subtracted at both places. So the direction of this vector is per x change. Per in x direction, if I have a value called x, then accordingly in y direction, the value is square root of a square minus x square. That is the kind of direction of vector. What is the strength of the vector? X component square plus y component square root. So x square plus a square minus x square root equal to a. So the magnitude of this vector is the radius a, whereas the direction of the vector is, this is what the direction is. If I say direction, that is per unit change in along x direction brings how many unit change in y direction, then it is a square minus x square square root divided by x. That is the kind of the vector direction, loosely we can say. So y component by x component. Per unit change in x direction brings how many unit change along the y direction. So vector is energy. So I can say if it is xi plus square root of a square minus x square j, then along x-axis x, along y-axis a square plus x minus x square square. If I take a point and connect from the origin, whatever the direction it is showing, the angle from the x-axis, that is the, so angle from x-axis can be said as tan inverse x a square minus x square square root by x, that much radian. That is the actual direction. So if this is the vector, this vector can go anywhere keeping the angle with the x-axis same. So vector is position independent, in the sense, if this is the vector, then this vector can be placed anywhere. Okay, independent of its position, but it will be always vertical. If it is a horizontal, it will be always horizontal. Okay, so vector can be said as kind of algebraic Cartesian points that we transform into a position vector. Position vector means a vector which passes through origin. So from origin to that Cartesian point is position vector. Okay. Now, if along this circle, if I keep changing p, if p denotes a coordinate, if I keep changing p, then the position vector is like this. If p is here, then position vector keep changing like this. Okay. Now we can say that algebraic equation kind of in some another form it is vector. So if I have algebraic equation that denotes a circle perimeter, then that algebraic equation I can transform into a position vector where x component is x and y component is fx. So vector has x component, vector has y component. Okay, if it is 3D, then it is z component. If it is nd, then it has n number of components. So generally vector number of component we define through m. M for monkey. Okay, so that is the traditional way where we define the vector component. So vector components are nothing but in machine learning, artificial intelligence, it is denoted as features. So if I have set of samples in data set, then each sample has 10 feature value, then each sample is denoted as a document vector. Okay, so it is called document vector, where the vector has, if it has m feature m, then this vector is called m dimension. It has m component, not necessarily that m components are orthogonal to each other. Okay, but it has m component. If there are so many samples, then we call it n samples. N samples where each sample has m m m n n for Nimros in Afghanistan, or n for kind of numpier. So n sample and m for monkey, m components in each sample, m features. So if we see if I say my data set is n by m, n into m, then it is n samples and each sample has m components. So each sample, if I denote through a vector called document vector, then it has m components. Like if I have a set of points, if each if this parameter of a circle is made up of set of points, then each point has, if I denote through a position vector, then this vector has m equal to 2 components. One is x component, one is y component. Now we started with algebraic equation y equal to square root of a square minus x square. If x is independent component and y is dependent component, then it makes a circle. If I connect all the y, if this is x axis and if I keep changing x value, then accordingly I get a square minus x square root as different set of y value. If I connect all the y value, then it makes a circle. Now each point, if I draw a line from origin, it becomes a position vector which has x component and y component. So analogous to the algebraic equation where x and y is there. But vector is more than algebra. So that's why we call it advanced algebra. If vector is more than algebra, means it has x component and it has y component. So x component itself is an algebraic equation, that is x, and y component itself is an algebraic equation, that is square root of a square minus x square. Okay, so if vector has m component, then each component is a function itself. It's an algebraic equation. That's why we landed up in advanced algebraic calculus. Advanced algebraic calculus means we are entering into a vector where vector has set of components and each component is function over the independent component. Independent component, dependent component forms a vector where each component, independent and dependent, can be a function over independent component. So if I say, if I have a position vector xi plus yj, where y is the square root of a square minus x square, then it has x component and y component. X component is x. So here I can call it x component is fx, whereas y component is gx, another function over x. This is one function over x, that is another function over x. What is a sphere? If I talk about a sphere, then it is x square plus y square plus z square equal to a square. That is a sphere. Now, a sphere is three-dimensional. If it is three-dimensional, then we have one independent component, that is xy plane. If I go to that independent component, that is xy plane, then there are two independent components. One is x-axis and one is y-axis. X-axis, y-axis. Two independent components constitute a kind of advanced independent component or hybrid independent component or composite independent component, that is called xy plane. Okay. So if I have xy plane, that is a composite independent component which has internally two independent components x and y. Now on the xy, now I'll set x in xy plane independent component set of values. The set of values will be x comma y. For each x comma y in the independent component xy plane, I have fxy function over x and y. Okay. If I have function over x and y, then z equal to fxy. So if x comma y is 2 comma 3, then the z value is function over 2 comma 3. Z equal to Python function name f that takes two parameter x comma y. So x square plus y square plus z square equal to a square is nothing but x square plus y square plus fxy square equal to a square. Okay. Now if I have a sphere centered on the origin, then if I have any point P on the sphere, then that point coordinate is x comma y comma function over x comma y. That is x comma y comma square root of a square minus x square minus y square. If that is true, then the vector, the position vector of this point P connecting from origin to this point is xi plus yj plus a square root of a square minus x square minus y square k. Now, this is the algebraic kind of representation in the vector as far as this representation in the concern. But this vector, the vector xi plus yj plus a square root of a square minus x square minus y square k itself, it has three components, m equal to 3, where each component is x, y and square root of a square minus x square minus y square. If that is true, then each component is function over independent component x and y, where x component is function is fx. If I represent it as fx, then fx is x, or fxy rather. The function, each component has function over x comma y. So fxy is x. Next, fxy is y, or we can call it gxy, another function. One is fxy, x component, then y component is gxy, then z component is hxy. Hxy is a square root of a square minus x square minus y square. So vector is kind of a representation where if I have any algebraic point, that point if I connect from origin, then what is the direction and magnitude, whatever magnitude we calculate. Every vector is an energy which has a direction, then it has components. Those components are nothing but independent components and then dependent components. These are the called as vector field or vector components. Okay. Now, vector is advanced. Why we are calling it vector as advanced? In a way that suppose I know that position vector of a circle is xi plus square root of a square minus x square j. If that is true, then vector direction is exactly like this. Consider that x is 0. At x is 0, that is the situation. If this is x-axis, then on this line x is 0. If that is the case, then p vector is 0i plus aj, means it is aj. Now I have a vector which has direction only j, and it has magnitude of a or direction. So j demonstrate the direction. So there is no I. So only j. So only it will be in along the j axis. Now I am not confined here. Consider that there is another vector, that equation is square root of a square minus x square I plus xj. Square root of a square minus x square I plus xj. If that is the vector, then if I move along the x-axis, along the perimeter of a circle, if I keep now at this position when x is 0, then the equation is ai plus 0j. If that is true, then at this point the vector is ai, means vector direction is in this. So it is kind of tangential vector we are talking about. So when x is a, then I, when x is 0, okay, we are talking about a square root of a square minus x square. When x is a, then I component is 0, whereas j component is x a. So at this point the vector has this direction, only j. So this is the vector we are talking about. But if it is xi plus square root of a square minus x square j, then this vector we are talking about. Okay, so this is the kind of scenario. So that typically, now what we can do on this vector equation, if I have x component of vector, that x component of vector, so generally whatever we are talking now here is vector is m number of component. First component, so generally it is referred as first component, second component, third component, up till m component, where each component is a function over all the independent axes or independent variables. So now if I have vector which has two components, then the first component is fxy and another component is gxy, where there is, then third component is hxy, where the independent variables are x and y. Or if m equal to 2, there m was 3. If m equal to 2, then first component is fx and second component is gx. Okay, so this is vector represented. This is called, typically called, vector field. An algebraic equation gives set of points. If I have a circle, then it gives set of points, whereas vector field give set of vectors. Different, right? If I have a algebraic equation y equal to square root of a square minus x square, if I keep drawing x, with variation in x. If I keep drawing y in variation of x, then I get a set of points. Okay, if I connect, it becomes a circle. But if I have a vector xi plus a square root of a square minus x square j, then for each x, if I draw this, then at e it will be every, if x is 0, then it is a j. If x is a, then it is a I. So with the value, so each point when x is a, means x is a, that is this point. At this point, the vector direction is this. This point, the vector direction is this. This point, vector direction is this. So if I have a vector, so end is the actual, the end of the vector. So if I have a vector, I would say vector field as vector equation. A vector field generates set of vector when we have set the value of independent component. So if I have independent component as x as a, x as 0, x as so many values, if x has 10 value, then this vector that is represented as capital F. If algebraic equation is represented as small f, then vector field is represented as capital F. Both are scalar. If algebraic equation gives me a scalar value, if fx is there, if I pass x value, it returns me a scalar value that is called y. Then capital F, that is a vector field. If I pass a scalar value, then it returns a vector xi plus a square root of a square minus x square j. For each value of x, it returns one vector, whereas y equal to a square root of a square minus x square, that is algebraic equation. For each value of x, it returns a value point x comma y, whereas for each value of x, it returns some I plus some j, a vector. So vector field is represented through a notation capital F. On top of it, we place an arrow. So capital F, in braces I can say X. So independent component is X or XY, X comma Y. Independent components are X comma Y. But if we set independent component inside the vector F, then it will give me a vector inside a vector field F, it will return a vector, whereas in algebraic equation fx, if I push the independent component, it gives me a point, a value, whereas vector field, that is capital F, if I push the independent component x, it returns me an vector, a vector. So if I have set of points, then I can think about an algebraic function. But if I have set of vectors, then I can think about the vector field equation. So vector field representation, vector field equation is a factory which gives set of vectors. Or if I have set of vectors, I can think of a vector field equation where it has so many components, m components. Each component of the vector field is a function over its independent variable. But if I have set of points, then with these points, I can think about an algebraic function where it has the parameter the function takes is the independent variable. Okay, so that is the story of that we have made a beginning in the vector field. We started from the algebraic equation and now reached vector field. What is now there is a new term that is called line integral. So that we will talk line integral. But let's see that this is a vector. This is a vector, or this is a vector. Suppose this is a vector. So vector equation is I plus 2j, or this is a vector field which is I plus 2j. If it is I plus 2j and it is a vector field, this proves that it would generate only one set of vector, that is I plus 2j. It is x component, it is first component and second component. They are not function over x comma y, or they are constant. So vector field is I plus 2j. So if it is I axis, it is j axis, then vector field is something like this. Okay, so suppose that I have this item. I have this item, and then vector field is like this. Now, since vector field is it is it is in this direction, so somehow it is pushing this item. This item can be moved only along x-axis. It cannot move vertically in no way. Now, if I have a vector field called I, then this is the vector field. Now, this vector through if because of this vector field, this entity is getting dragged. But if vector field is I plus 2j, then this is again dragged, but speed will be less because energy is in this direction. Earlier, energy was completely along the direction I want. Now, if vector is along this direction, then it won't move at all because energy is completely into it. Energy comes from bottom, then it passes from here. But if energy is like this, then it comes from bottom. While it is passing, it will push it. But if it energy is like this, along x-axis, then it will completely push. Okay. So what we are trying to achieve now? If I have a vector field and if I have a direction, then what is the energy essence I get in that direction? Okay. So suppose that there is a water flow. There is a water flow, heavy water flow, steep water flow. I am in a New Zealand river. I have heard, I have never been to New Zealand, but flow is very high in the rivers. So I am in a river, and river water is flowing in a direction with high current. Now I am inside the river, but I am in a kind of so if this is the water direction, then I am standing in the water here. And then it is something like that. I have a chain. So chain in the way, the chain is placed like this. Okay. So I can move only in this direction. I cannot move in this direction because chain stops it. Now, how much displacement I receive because of the water? No displacement. It is at 90 degrees. So if current is very high, but I am inside a chain and I can move perpendicular to the water only. If water is flow is very high, I am sticking to the chain. So there is no work done. Work done by water, since there is no movement in me, so work done by water is nothing. But think that water is little tilted in a way that this water, if this is the water direction and I can move in this way, this is perpendicular, but water is slightly like this. Water is going in this direction, or in this direction my chain is like this, or water is going in this direction, then my chain is like this. I can move along this direction. So if water will make me move slightly in this direction. How much it is? Then it is called direction, vector field direction, and the direction of the path dot product. Okay. If I do dot product of these two, then I can see how much is the vector's essence I can see in that direction. Okay. So if I have a vector I plus 2j, then what is essence along I direction? That is 1. What is its essence along z direction? Then I plus 2j, then 2. What is its essence along the I plus 2j in this direction itself? Then it is 1 square plus 2 square. That is the essence, that is the magnitude of the vector. But what is the essence of this vector along x-axis is 1. along y-axis 2. Along this axis only 1 square plus 2 square square. So if I have a vector field and I want to see its essence along a particular direction, I have to do that direction. I'll create a unit vector. Then that vector dot product of this unit vector will give me the essence of this vector along this vector. Okay, or if I say that how much energy, if suppose this vector, the vector field is a force, vector field is a force, vector field is a force. If vector is a force, then how much energy I feel along this direction. Okay, so how much energy I feel along this direction. So if I have a vector field I plus 2j, then vector field along x direction, if someone is moving 10 meter, someone is walking for 10 meter, or there is an item that is kept on x axis, it moved 10 meter. Okay, there is a force that has a direction I plus 2j, magnitude 1 plus 4 square root of 5, direction I plus 2j. If I talk about only direction, not the magnitude, then it is I plus 2j divided by square root of 5. If that is the vector and there is an item that moves 10 kilometer along x-axis because of this vector, then how much work done that is done by this vector moving this object 10 meter along x-axis? This is the question. How much work is done by this vector moving it along x-axis? Okay. So if this is vector field F, then that field dot product of the x-axis. So dot product means it is I plus 2j dot 10 I, that will become 10. So that is kind of 10 10 10 joule or something like that. So that much energy that is imparted on the object, that's why it moved 10 meters. Okay, so this is called line integral. Line integral in the sense, if I have a vector field and I have a particular line, then along this line what is the essence of this vector field that is generated on this line. Okay, vector field dot product of this line. Consider that again I am in a what, I am in a water, or I am walking in a high speed wind. High speed wind. Now I am walking against the wind. Wind is coming and I am walking against the wind. Now if I walked 100 meter, then I push some energy from my body, so I walked 100 meter. But I feel that I pushed more energy if there was no air. If there was no air, then I moved 100 meter. If there is air that is coming against me, exactly opposite to me, then I moved 100 meter. This proves that I pushed more energy. How much energy I received from the air that is against me? Or if I am moving along 100, if I am moving 100 meter and wind is coming from my back and it is pushing me. Okay, if wind has a force, and then how much energy I received from wind, so from my body I pushed less energy. So force, whatever the force vector I am receiving from wind, and what is the distance I have traveled 100 meter, that much energy is given by the wind. Okay, so that is called line integral, in the sense that vector field multiplied by the distance along the vector field. So along the line. So if I have a line of movement, if I have a line of movement and I have a vector field, then how much vector field is imparting energy in this direction? I have to multiply this with dot product. If air is moving perpendicular to the person is moving, then it is not imparting any energy on the person, because the vector field of the wind and vector field of the direction of the movement is 90 degrees. So that the angle is 90 degrees, then dot product is 0. So the energy imparted on the person when he is walking at perpendicular to the vector field is 0. But if it is pro, then energy is given by. If it is against, then it is stopping the person. Or if it is at angle, then dot product. Okay, then that much energy it is. So if wind is passing with energy of 5, now question comes back again. Now if I have a vector, energy vector, and it has a direction I plus 2j, which has a strength of square root of 5. If that is true, then if it is kind of moving, if it is kind of, if there is an object here kept and that object is moving, then how much energy because of vector it is feeling, that it is being supported to the movement of the item along the x-axis. So that energy is 1, not a square root of 5. Because if I do dot product with this unit, only 1 is coming, vector field only 1 is coming along this direction. Okay, even though it is 5. So if it is moving 10 meter, the net energy that it receives from the vector is 10. If it is moving 10 meter and vector is also in this direction, then net energy it is receiving from the vector is a square root of 5 into 10. So multiplication of the vector into the length, along the line is called line integral. So we will proceed on this line integral, because if I have a vector, and if I have a line, then along the line, what is the essence of the vector I am getting in the line? Now this vector field, okay, if this line is straight and vector field is also straight, then we can just do the dot product. Along the full line, I am receiving same angle vector field. So dot product of these two will give that at each point along the line, I am receiving same essence of the vector field. What about vector field itself is changing? Some point, okay, if this is the line, then at this point the vector field is like this. At next point vector field is like this. Next point vector field is like this. Next point. If I have a line and along the line, if I take 10 points, then at 10 point the vector field direction is different. This is one scenario. Line itself is a changing curve. Line itself is not a straight line. A line itself is a curve. Line itself is a curve, and at each point in the curve, the vector field I am sensing has different vector. Second case. Third case is line itself it has a direction. We can say line in this direction, line in this direction. So this much complexity, if it comes, then a person is moving along a line and there is a wind, then person if move along a curve, then from this point, then he is moving to the end. How much energy he received from the wind? When wind has a direction, but wind at each moment, now this person, okay, so if person is walking in this direction, straight line, and wind is in this direction, then how much energy he is receiving from the wind? So that is dot product of the wind direction and the person direction. that much energy he is receiving from the wind. That is the essence of wind energy along this direction. But person is moving along this direction. Then how much energy he is receiving? So at each moment in the curve, the direction of the dot product is changing. If this is the wind, then this wind and dot product is different. This wind dot product is different. This wind dot, because angle is changing. Can you see? Okay. Now the wind, when he was at this direction, at this point in this path, then wind is like this. When he reached here, wind changed his direction to this. When he came here, wind changed his direction to this. When he came here, the wind changed his direction to this. If that is the scenario, then from beginning till end, how much energy he received from wind, or how much energy against him he received from the wind. So this is form of called line integral in vector area. So we will see more in it, where we, like if I say that if person is moving in this direction, and if I have the vector field of wind as a force, if I consider as force, then force into displacement is called work done. So if this is the distance person is covering from here to here, and wind is in this direction, wind x component if I take and multiply by the distance, then that much energy is given by wind to a person. So if it is I plus 2j and person move 10 meter, then I plus 2j, if it is x axis, then 10 is the amount, 10 unit is the amount, that is the energy it received because of the wind. But if wind is in this direction and a person is also moving in this direction, if he move 10 meter, then net energy transferred by wind to him is square root of 5 into 10. More energy he is receiving from the wind if he is going along the wind. So what is the line integral of the vector field along this direction? If this direction is 10 and vector field is f, then f dot 10 I. F dot product of 10 I. So f is I plus 2j, and here it is 10 I, then 10 unit of energy forced into displacement is work done. That is the energy, that is joule. So a person is moving in this direction, and wind, that is a force, it is in I plus 2j, then energy that it has received from wind is 10 unit. If person is moving along y-axis 10, then energy it received from the wind is 20. So I say line integral of vector field along x-axis where distance is 10 is force dot product of the 10I. This is called line integral. Line integral of the vector field. Vector field multiplied by the line distance along the vector field. So if I am rowing in a water, water is moving in a direction, and I am rowing, I am taking some zigzag path. Sometimes I come around the water, sometimes I go along with the water. If from point A to B I travel, and water if I consider as force, then how much energy I believe that I received because of the water. So if I take zigzag path from A to B, or if I take zigzag path from A to B, and water, every point water direction is also changing somehow. This may not be the general case, but somehow there are stones in the water, and somehow it is changing the direction. Then how much energy I get from the water? So this is called line integral. Straightforward is person is moving in a straight line, and water is in straight line in some direction angle. How much assistance I get from water? That is direction of the force of the water dot product direction and magnitude. So if I do dot product, so if this I consider as line of length, then it is line integral. Now both are vector now. This has a direction that keep on changing and water has a direction that also keep on changing. If I need to calculate the net energy that is imparted on me supporting or against it from the water, that becomes a calculus line integral. So that we will proceed on, that should not be very difficult, and we will see many enjoyment in the line integral is concerned. But if you understand algebra basic and vector which has direction and magnitude, then you can make it. So we will proceed on line integral more.